Today's webinar. Today we are looking at GIS and BIM integration. We are really excited that you have found time to join us. So again, I will be taking you through this session with my colleague. His name is Elijah. I think he can just introduce himself. Elijah.
Thank you, Evelyn. Thank you everyone for finding time to join us in this webinar. I'm Elijah Chiang. I work as a BIM specialist with the World's View Technologies. And welcome. Looking forward to interacting with you in this webinar.
Thank you, Elijah. So, and again, in case you have questions in the course of this presentation, kindly use the chat section. Our teams are on standby, and they'll be able to engage you as well as respond to questions that you may be having in the course of this presentation. Then again, just to mention, the webinar is being recorded and will be available on our YouTube channel. The link to our YouTube channel, that is Esri, Eastern Africa, will also be shared on the chat section. So today's series, this is the second series in the GIS and BIM integration webinars. So we are looking at integration GIS and BIM, and today specifically we'll be focusing on the infrastructure development workflows. So for this particular presentation, I'll be taking you through the GIS bit that's providing the content for the infrastructure development project that we are working on with Elijah. And then Elijah is gonna provide the content that's using BIM. So we believe that GIS and BIM are really important for decision making, especially for professionals within the built environment, or what is famously known as the AEC industry. That's the architecture, engineering, and construction industry. And GIS has been improving many industries for many decades. BIM, on the other hand, has also continued to support the professionals mainly in the AEC industry. So the main focus for this integration actually is initially we've had exchange of information and data between the different professionals. So for this case, we're looking at a project lifecycle. So initially we've had exchange of information being file to file. Then over time, we've had that changing from the file to file exchange to maybe file to the cloud, maybe from the desktop to the cloud. And so the focus actually that we're going to look at today is mainly desktop to the cloud as well as cloud to cloud. So really this integration is really, really important in just ensuring that people are supported well within the entire project lifecycle. And so the integration mainly focuses on better collaboration. So of course, in any project, there are different experts or different professionals working within that particular project. And the tasks of this particular experts or professionals are actually interdependent. So for instance, the person at the planning bit, the design bit, and so on and so forth. So there's need for better collaboration. Then we're talking also about improved workforce. So think of people working in the field and having to coordinate that with the people in the office. So we're talking about better field to office coordination and the general flow of information. And of course, we are thinking of strategic partnership, being able to leverage on alliances to deliver complete solutions for different industries. And that's why BIM is really coming in handy. So we're going to look at how best you can be able to make use of this. So as I mentioned, I'm going to take us through the GIS bit. And the GIS bit that I'm talking about here is the Esri Arcgis platform. So this is based on the Arcgis platform. So this platform is a complete platform for managing and applying geographic information. And the platform has various components as well as linking these components to the various users. So within the platform, we have users working with information using the different applications connected to this platform. So we have different types of applications. You can see on my screen here, we have desktop applications, we have various apps, mobile application, office application. We also have APIs. So we have quite a range of the different applications within this particular platform. And then this platform also provides identity and information by linking the various people and apps to the platform. And the other thing that I have to mention is that the platform also provides identity and information models. So these information models consist of maps, we have layers, and so on and so forth. And then also within the platform, all the information products within the platform are powered by services. So we have services within our platform, that's the Arcgis Online platform, as well as the enterprise portal. And then in terms of deployment of this platform, we have various options that you can be able to use to deploy this particular platform. We have what we are calling on-premise deployment. So for this particular one, we mainly have Arcgis Enterprise. Then we have what we are calling online deployment, that's software as a service. And then you can also have a hybrid of the same. You can have an hybrid of on-premise deployment as well as Arcgis Online deployment. And then the other thing that I really have to mention is that this platform is actually improving, and we have a lot of improvements and integration with new innovations. And that's why today we are talking about the GIS and BIM integration. So I also want to take some time just to talk about the state of integration in terms of BIM and GIS. So we have various, so far we have various solution products that have been integrated within the BIM and the GIS platform. So you can be able to see here we have Autodesk, the various products, the BIM products. We have Autodesk Civil 3D, which will be one of the main solutions that we'll be looking at today, connected to Arcgis Online and Arcgis Enterprise. This is mainly through the Autodesk connector for ArcGIS. We have InfraWorks, which we covered during our last webinar, also connected to Arcgis Online and Arcgis Enterprise using the Autodesk connector. And again, notice the direction of the arrows. So there's both like you can be able to connect from Civil 3D to Arcgis Online and from Arcgis Online to Civil 3D. And then we have Revit, from Revit to Arcgis Enterprise using the Arcgis Pro ETL. And then we also have BIM 360 and Arcgis Pro. This is with the latest version of Arcgis Pro. That is, we are currently at Arcgis Pro version 2.6, so that's also possible. And then in terms of what is coming soon, so there's continuous development just to ensure that we have seamless integration between both BIM and GIS. So we're looking at the cloud-to-cloud kind of integration. That's from BIM 360 to Arcgis Online or Arcgis Enterprise. Then on the right of my screen, we have the data sets that you can be able to integrate within these platforms, within these two platforms so far. So we have vector data sets, like what we're going to look at today in the course of the presentation. We have CAD data sets and we have imagery. And then in terms of documents, we're looking at having real-time data sets, tabular data sets, and more aspect of 3D data, as well as LiDAR data sets. So yeah, so that's what we still have in development. So for this particular session, I'm mainly going to take us through the creation or providing the context within one of our main applications, and that's Arcgis Pro. So Arcgis Pro is the latest desktop application that we have. It's a 64-bit multi-threaded application. So what this means is that we have faster processing as well as display and visualization. So you're able to execute various tasks using the geoprocessing tools, as well as the tools are running, you're also able to carry out other tasks. And then we have the contextual user interface. I must say that the Arcgis Pro user interface is quite friendly. If you've used any of the Microsoft applications like Microsoft Word, then it should actually be very easy for you to work with Arcgis Pro. So the user interface is also very friendly. And then the other thing is the close integration with the platform. That's the ArcGIS platform. And of course, what we are talking about today, the BIM integration, as well as other integrations. So you can actually be able to import work that have been done in other applications within the ArcGIS platform into Arcgis Pro. And again, what we're talking about today, that's the BIM integration. Then we have the combination of both the 2D and the 3D experiences within Arcgis Pro. This is really great. For those who've used maybe ArcMap before, you'd have to look for ArcScene and so on and so forth. But within this particular platform, we actually have the same in the same interface. Then we have quite a number of analysis tools. You can be able to perform various queries and so many other capabilities within the Arcgis Pro platform. So in terms of the licensing, how Arcgis Pro is licensed, actually the licensing depends on how you actually want it. So the client can be able to determine how best they want to use the licenses depending on the work that they're doing. So we have the named user license, which is the main, which is actually the default licensing type for Arcgis Pro. So with the named user license, what this means is that you're able to get the licenses, the Arcgis Pro license assigned to you by the administrator of your organization. And by the organization here, I'm talking about the Arcgis Online organization or your enterprise organization. So you'll have your administrator assign you the license as well as the extensions that you may need within your organization. So we have the named user license. Then the other license that we have is the single-use license. So the single-use license, what this means is that it allows you just have one person using that license on a single machine. Then we have the concurrent use license. So in case you, especially for organizations that have maybe quite a number of employees and you need to have multiple people using the same license, then you can take advantage of the concurrent use license. So in terms of the licensing, we have those three options, and again, it depends with what you want and how you want to have it. So you can have the named user, you can have the single use, and you can have the concurrent use license. So what I'm going to take us through today in the demonstration, I'm mainly going to provide the context for our project site. So this will mainly be this is actually a planned area. The project site that we are looking at is a planned area. And so for this particular site, we have a lot of information that we've been able to put together within Arcgis Pro. So we have the parcel information for this particular planned area. It's actually a subdivision of a planned area. And we also have infrastructure information. So we're looking at the road networks, we're looking at the utilities, the water utilities within our project site. So Arcgis Pro is mainly going to provide the context, and then BIM is going to provide the content. And then also within Arcgis Pro, you're able to have both 2D and 3D visualizations, as I had already mentioned. So I'll be able to provide these within Arcgis Pro. So for me to be able to have this information shared with my colleague whom we are working with in the same project, I'll share this information to Arcgis Online. So Arcgis Online is also one of the main solution applications within the platform. So once I have finished authoring my content within Arcgis Pro, then I'll be able to publish that information to Arcgis Online. So again, I need to mention that there are various options that one can be able to share this information within Arcgis Online. So you can share that information as a web layer, like what we're going to just look at in the course of this demonstration. So it can be a feature layer, it can be a tile layer. So for this particular one, we're looking at being able to share this information such that the person getting the information on the Arcgis Online platform can be able to visualize, can be able to query, and can be able to edit that information. Then you can also share that information in the form of web maps. So if you're sharing the information of web maps, it means that you have the map with all your layers published to Arcgis Online. Then you can also be able to share that information in the form of web scenes. That's 3D web scenes. So that's what I'm going to take us through in the course of this presentation. So I'm going to invite Elijah to take us through the BIM bit before we go to the demonstration. Over to you, Elijah.
Thank you, Evelyn. So I'll pick up from there. So you have introduced us to GIS with some elements of BIM. So we'll just pick up from there. Just to mention that, so BIM traditionally was referred to as CAD. So people have majorly migrated from CAD into BIM, basically to enhance the way people design and even communicate and integrate various data that is required for their design purposes. So as you know that the engineers rely much on the work done by surveyors and GIS analysts that enable them to integrate the existing site condition plus what they're proposing to have on that particular site. So we will develop the plans and concept and then develop it further to the detail. So with BIM, if we talk about connected BIM, we are ideally looking at a more interconnected process that starts from the planning phase going through up to the operation and maintenance of the same project. So this has been very difficult in the previous years where engineers were relying on manual and traditional processes to integrate their GIS data with the design that they are intending to develop. So with the latest advancement and technological trends that have been growing in the AEC industry, this has now been made possible. And also Autodesk has developed, Autodesk and Esri, through the partnership that was mentioned by Evelyn, has enabled this, where we are now able to build or design on the context of the existing site condition. So from a designer's perspective or from the engineer's perspective, the focus will be on Civil 3D. We'll basically look at how we can use it to do our design and documentation. So I will take a brief overview after having integrated the GIS data within my BIM platform, so that I can basically show how the engineers will utilize that GIS data to help them plan and develop their design through the various design stages. So just be a quick overview showing how we can streamline that work, and also redefine the various construction documentation that would be required for them to move to the next stages of the design. So traditionally, this is how people have been bringing their GIS information into their models. So where we have, maybe you have your working desktop, the desktop on which you work, but you talk with the surveyors and the GIS guys to give you the data in the form of PDF, text files, XMLs, raster, and what have you, shape files, so that I'll be able to import and bring them into my model so that I can start my design. But we know the challenges that this come with in terms of being able to, first, you need to define the coordinate system every time you are importing the files. The data is not also dynamically linked with the GIS platform where they were analyzed. And also it's not very easy to get up-to-date information. And the fact that every now and then when you're trying to import and save to different file formats, there are usually some errors that are incurred. So what you're proposing through this workflow is where we will now be able to see an integration where every now and then, if I need to get information from the GIS, I just need to log in to their Arcgis online that they use to publish and share the information to the designers. So we not have to be saving, importing, or maybe converting to different file formats. I'll just quickly be able to go into the cloud where the Arcgis sits. Then I'll be able to select the specific data in the data form of layers, or whichever format that was defined by the GIS guy when they were publishing that information. And whichever phase of the project that I'm interested in, whether I'm in the planning phase, the design phase of the project, or when you're actually doing the building or whatever was designed, we are able to link up with the GIS data and bring them to our design model. So from an engineering perspective and the design perspective, this is something that that's what we are looking at, where if you go to the 3D model, incorporating all the existing infrastructure plus what you want to propose, whether also buildings, we're able to have those integrated within one BIM model, as you can see in this particular slide. So whether I talk about the water resources, the elevated bridges, drainage, road network, all those other infrastructure components that you may find within a proposed site. But today the focus will be much on the design, but not building up the context. Because we assume that whatever you know to do today is to develop the design elements, like proposing the geometric design requirement for a particular road within the reserve that has been planned from the previous design phases. So I will hand over back to Evelyn to start us off with the demo, so that I will continue with this once I get the data from her.
Thank you so much, Elijah. So the next bit that we are going to is the demonstration. So we are mainly going to have a brief demonstration of what we've been talking about. So I'm going to launch my Arcgis Pro. Arcgis Pro is one of the main desktop applications that we have within this particular platform. So I'm going to provide the context within Arcgis Pro. So this is Arcgis Pro for those of us who may have not interacted with this particular application. So this is Arcgis Pro, one of the main desktop applications that we have. So this is the interface that you actually get when you launch your Arcgis Pro. So, and I think what I need to mention is that Arcgis Pro, when you're working in Arcgis Pro gives you the flexibility of actually having different projects. Like you can be able to see here, there's a list of the recent projects that I've actually worked on. So you can be able to organize your work in terms of the projects that you've done. So each project within Arcgis Pro has the layers, and everything that you've actually been working on within that particular project. And then I mentioned that there are 3 licensing models for Arcgis Pro. So what I'm actually using is a named user license. You can actually be able to see that I'm logged into this particular organizational account. So I'm using the named user licensing model for Arcgis Pro. So I'm just gonna create a new project. Let me just call it GIS BIM demo. So when you create a new project within Arcgis Pro, this is the Arcgis Pro user interface. So we have different parts within Arcgis Pro, like what you're seeing here as it still loads. On the catalog, we have different folders, and anytime you create your project within Arcgis Pro, we have these folders automatically created for you within your project folder. So your project folder will have the databases, the folders, the maps, and all that. So for this particular one, again, we have a geodatabase created for us. That's the GIS and BIM demo geodatabase. So it's actually easier to work when your dataset is in a geodatabase. So a geodatabase acts as a single repository for all your data sets. So if you're working in a project and you have several data sets, you can put them within a single within the file geodatabase. Of course, we have other types of geodatabases as well, but for this particular one, we're mainly going to work from the file geodatabase. So I have data for this project that we have been working on with Elijah. So I'm just gonna create a folder connection. So to create a folder connection, go to folders. Then I'm going to navigate to the place where I have my data sets for this particular demonstration, or for this particular project that we've been working on with Elijah. So I saved them in a geodatabase. So I have various data sets about my project area. So I'm just gonna add the data sets to the visualization so that you can see what we actually have. So we have parcel data sets within that particular project area. We have road data sets within that particular project area. And then we have water distribution networks. So again, those are some of the very crucial infrastructure data sets that you want to have within a particular project area, or actually when you're planning for a particular area, you need to have all these information within your project area. Then again, I just want us to look at some of the attributes that we have within our data sets. So let me just zoom out a bit so that we can get a better overview of the project extent. And then I think I'm gonna change my base map. I think we can have an imagery base map so that you're able to see the background of the project area well. So actually the project area is it's actually an undeveloped area. So it was easier to have like the subdivision within this particular area that is not developed. I think I'm just going to switch to something that is already done. Allow me just switch to this and load the same data sets that we have. Let me just try and highlight the color for the parcel so that you're able to see it clearly. Yeah, so we have the parcel information within this particular area. Then we have the road networks within our area also, so you can be able to see that on the map. So this is actually a subdivision for an area, a planned subdivision. So normally when a subdivision is done and this has been submitted for approval, then the surveyors can actually go to the ground and the area can be surveyed, and the various parcels within this particular project area can now have the LR numbers. So let me just label the parcels using the LR numbers. So the assumption here is that this particular area has been surveyed, and we have the LR number for the different parcels within our site. Then again, when you're planning for any particular area, of course, we have the different land uses for that particular area. So again, even for this particular project area, we have the land uses for the different zones within this particular area. So we can try and symbolize just to get an idea of what this looks like in terms of the development. for this particular area. So we'll symbolize using the land use so that you can be able to see the land use colors within our project area. And then of course we have like the standard land use colors. So let me just try and pick maybe some of the common land uses, like the commercial land uses will definitely have a red color code. Let me just try and symbolize so that it's a bit more realistic. Yeah, we can have that. So we have various land uses within our site. So again, if you click on a particular parcel here within our project site, you're able to see the details or the information about that particular land use, that particular parcel. You're able to see the land use, you're able to see the area, you're able to see the floor number, and then I just tried putting a bit of what if actual implementation is done, what this could be. So we have something on maximum floor count based on the planning standards. So this is the information that you have for this particular planned area. So again, it's really important to have the infrastructure aspect of our area. So we have the road networks within our project area. Then I just picked on a section of the project area, and you can be able to see we have a section just showing what the utility, where the utility networks will actually be within the road reserve. So again, when you're planning for a particular project area, you're able to give to provision for the different uses within that particular area. So again, I just picked a section just showing where the utilities are passing, and again, they're just within you can see they're actually within the road reserve. So you can have various utilities, you can have water, electric, all these within the road reserve. So what Elijah is actually going to focus on is the infrastructure development. He's going to focus on the road infrastructure, and maybe also touch a bit on the utilities infrastructure. So this information provides the context for him to actually be able to do the design. And now that the plan has actually been approved, and or rather this subdivision has actually been approved, then you can comfortably move to the preliminary design phase. So that's what will be the focus of our presentation today. So for Elijah to be able to access this information, I'm going to actually share this information to an Arcgis Online account. So you can be able to share the information to an Arcgis Online account or to an enterprise portal. Then using the Autodesk connector for ArcGIS, he will be able to load the same information that I have here in my Arcgis Pro in Civil 3D and actually do the designs. So again, as I mentioned, there are various ways of sharing information from Arcgis Pro. So you can be able to share your information as a web layer, you can be able to share your information as a web map, or you can actually be able to share your information if you're working with 3D data as a 3D web scene. So for this particular case, I'm just gonna publish this information to Arcgis Online, where Elijah is actually going to access the same information and use it for the preliminary design within Civil 3D. So I'll simply come here and publish this information. So this is the interface that you get when you're sharing your information from Arcgis Pro to Arcgis Online. So it's gonna require us to put in the name of the layer that we are publishing, and then so for this particular one, maybe we're just gonna call it GIS BIM demo data. Let's just call it BIM. Then we can give a summary of what the information is all about. So maybe we just maybe we can just say this is demo data, and then tags just make it easy for you to be able to search for information. So in case you need to search for that information using the tags, it will actually be very easy to be able to search for that information. So maybe for my tags I can have GIS and BIM. Then, of course, we are publishing these as a feature layer. This will allow Elijah to be able to edit the data if need be, query the data and visualize. So we are publishing these as a feature layer. So once you're done, there are options down here. You can be able to analyze the the layer before you actually publish. So when you click on the analysis bit, you're able to see if there are any errors or warnings before you get to publish your data sets. So once that is done, then you just click publish, and your data will be published to your Arcgis Online account. So again, for the purposes of this presentation, we're not going to have to publish that. It may take a while. So I'm just going to take us online where I have that information published. So I'm just going to take us to Arcgis Online where we have that information published. So I'm going to search for Arcgis Online right here. Then I'm going to sign in with my organizational credentials. So I'm using the same credentials I was using in Arcgis Pro, since I'm using the same credentials I was using in Arcgis Pro. So I have the data sets published to my Arcgis Online account. So when you publish, so this is Arcgis Online. So when you publish your content, it's actually automatically shared under the content section of your Arcgis Online account. So it's just taking a while. Then it's gonna show us the content that we have under my content. So you can be able to do a lot with Arcgis Online. You can be able to create, suppose you had published data, you can be able to create web maps and even web applications. So I have this feature layer published to my Arcgis Online account. That's the GIS and BIM demo data, how that looks like. So it's the exact data that I actually have in Arcgis Pro. So from here now, Elijah will be able to use the Autodesk for Arcgis for Autodesk connector to actually access the information that I have published to Arcgis Online and actually do the preliminary design within Civil. So just to show you how the data looks after we have published. So it's actually the same data sets that I have within my Arcgis Pro. Give it another minute or some few seconds. Yeah, so it's actually the same data of our project area that has already been subdivided. And so Elijah is going to access these information and actually do the designs in Civil 3D. So I'm going to hand over to Elijah so that he can be able to access this information and actually do the designs in Civil 3D. Over to you, Elijah.
Okay, thank you, Evelyn. So I'll share my screen once again. Okay, so what I've done, I've opened the Civil 3D right now. So it's the software that I'm going to use to integrate at this level. So it's not more of a concept, but we assume that we are going to develop some level of detail depending on the plan that has already been developed. So we're just going to provide the detailed requirement for our sewer lines, for example, or water distribution network, the roads. So initially what I would have done, I would have maybe asked Evelyn to save those files for me, maybe somewhere, and share via mail or maybe within a file transfer protocol. In this case, she has published them in Arcgis Online. What I'll do, I'll just go into my Civil 3D, and then in the Insert tab, a tool has been developed that's called the Autodesk connector for ArcGIS, which allows me to directly get information from ArcGIS Online. So if I click on Autodesk connector for ArcGIS, it will open up and take me directly to the ArcGIS Online, where the GIS information has been published. So basically the layers giving the information about the details that have been given by the GIS guys. So my work is just to search. So then I would have logged in, so I'd pre-logged in before this. So usually you need to log into to that specific account through which the data was published, or it could be within your organization's content or a particular group content as been illustrated. So in this case, I've logged in with the same credential that been used to publish that information. So what I'll do, I'll just filter by searching the specific content. So it's the GIS BIM demo. So then I will select it. So also you can see immediately I open this. One of the things that you could have noticed is that it immediately takes me to the project context within the map, so that I don't have to start searching and browsing to where the project ideally will be located. So my work is just to quickly open, and it will take me to the context where that my project will be done from a design perspective. So what I need to do from the layers that have been published, I need to select the specific equivalent layer that they'll be taken to when they come in Civil 3D. So like you can see, we have nodes. So like this ideally nodes, we refer to them as junctions or our structures within the design space. So they have been published as nodes. So I will select structure to allow the product to convert them to the equivalent design elements. Same also subdivisions. So subdivision ideally should also be parcels, but that is missing. So in this case, I will just say that bring my subdivisions in form of feature lines. Then parcels, bring them in form of plots. Then road networks should be brought in form of feature lines. Then the water distribution ideally should be brought in form of gravity pipes. So that's ideally what I should do. I'll just select the specific features as been published by the GIS analyst. So if I was to bring all of these all at the same time, that will take time. So I'll just need to select maybe a few of them. I will uncheck a number of them and only bring in, let's say, parcels. And I'll bring in, let's say, just parcels plus road network, because if I was to check all of them, ideally that will take a considerable amount of time. For demo purposes, let me just select on parcels. So if I click add, you see on the bottom left of the screen, it will tell you the number of features that you have selected. And if possible, you can add them to your design project. So again, you see, in this case, this will enable to bypass a number of processes. If I were to manually bring that, ideally would have been worried about the specific file type and the coordinate system through which to import. So it will go back into Civil 3D and will show me the progress. It will start importing the Arcgis data, and it tells me the specific one that is bringing in. So in this case, it brings in and creates them within the context. So you see, it tells you that it's creating the parcels for my use. So parcel creation also forms a very integral part of designers, in that we usually rely much on cadastral survey. So where there is that cadastral survey is not available, once that information is developed by the GIS guys in the Arcgis, we can go to bring it in directly into our plan, because we also need to know if the reserves that have been provided for the roads are adequate or not, and if not, how best should we configure the design to accommodate whatever is already available. So I'll just give it some few seconds to finish importing. Or as it finishes importing, I'll want to check on one thing. So I want to integrate Civil 3D and another software we call InfraWorks, because for me to design, I also need a topo. So we're just assuming at this stage that the topo, maybe the surveyor not already gone to site, because we're still at the earlier stages of the design. So if the surveyor has not gone to the site to maybe collect the data, I've used InfraWorks to map the same project area. You can see maybe the river, the context, the existing roads and what have you there, and the footpaths. So I've used this. I'm going to extract a file format we call IMX to give me a file that we're going to use in form of our topo. So IMX is just an extension that Autodesk uses to allow communication and data sharing between its platforms. So I already did that. So this will enable me to get the topo that I can be able to put in the background for my design as well. So if I go back to Civil 3D, you can see it's already been done, and you can see the parcels, the subdivisions, the way they have been defined from the GIS. So you see, this is now within the CAD platform. You can now see our lines. You can even see the parcel numbers and the various way that they were organized within the GIS platform. So what I can now quickly do, I will go into my geolocation and put in a map so that I can contextualize the design within. So usually photograph or the imagery enhances the visualization of what we have within the background of the information. So my work as an engineer is to either now start providing for the specific corridor requirement, like maybe if you're looking at a road, what's the corridor reserve that is provided? What's the number of lanes that ideally should be accommodated there? And if you're looking at sewer lines, what is the demand within that particular area and what will be the discharge from the demand. Like maybe I say that a particular household consumes, each person in a household consumes, let's say 120 liters of water per day. If a household has maybe 5 people, that basically means that you're going to have 600 cubic of water being demanded within that particular household per day. So what are they going to discharge? So using those engineering analysis, I should now be able to provide for the actual sizes of the stormwater and manholes that are required to accommodate that. So this, I've only imported the parcel. So if I switch back to the one that I'd done previously, where I was able to bring in the sewer line, the proposed networks. So I'll just give it some seconds. So be able to see, if I were to zoom in, you should be able to see it shows me, based on the current plan, these are the proposed pipe networks, and they are just running adjacent to the parcels. And you can even see the way the plan also shows the proposed locations of the manholes, the proposed connectors. And right now, to me as a designer, I can now start performing analysis. So you can see there are tools within Civil 3D which can allow me to analyze the performance of these pipes and if they are going to carry adequate water for the design purposes. Because when someone is planning of developing a particular area, those are some of the very basic infrastructural needs that must be provided. Is there water? Is there sewer? And are there roads? So that's what we are going to develop at this stage. So what I need to do now, I'm just going to import that topo surface so that I can proceed with my design, because I already have the plan basically showing me the proposed road reserves. So what I need to do, I will go into the InfraWorks tab within my Civil 3D and say import IMX. So IMX is the file which I mentioned was containing the information about my topo. So if I just click open, it will open up that topo surface and also integrate it directly within my cadastral map. So again, I hope you are also seeing. I hope you are also seeing the relationship. So I think the project extent was slightly out of the context, but I'll just use that as an illustration purposes. So what you can now be able to see here in this case that we are able to, even if the surveyor would develop their survey data later on in the stage, the engineers and the designers are still able to integrate that with their context. So like what we want to do now, right now, is we'll use the tools within Civil 3D to perform our design. So if I go to my home, we'll find that there are specific tools for design. So like if it's a road, the first thing you now need to do as a road, you define the alignment. The alignment must correspond to the corridor, in that it must follow either the center line of the corridor. Maybe you can use some particular offset features to define how you'd want to do that. So you can see if I click on the alignment there, you see there are specific features which allow me to do that alignment, either from the existing objects or from scratch, where I just define that let my alignment run from point F to going through to point B. The same also, I allow specific tools which can allow me to now create a specific road assembly. So like if I say I want to create a road assembly here, what I now need to do, I'll just call it, maybe it could be street. So in this case, these are just short roads, we can call them street. So I'll just call it street 1. And I'll say that this street will be defined by a single crown road and using all corridor sets to be able to do that. So I'll just say, okay. Then I'll place it here now as my assembly for the road. So what I now need to do, I'll combine the various features within Civil 3D that enables me to define how that road is going to be formed. So like if let's say if I'm going to add the length of that road. So typically there are some standards that are followed based on the functions of the road, whether it's for access or for mobility. So in this case, it's going to be for access purposes. So what I'm interested in is just to provide the minimum. So I'm going to provide access purposes. I'm going to say that I will have this road being approximately, so I'll just repeat that. So I'll say lane. Then if the lane assembly opens, the property of the lane here, I can now start defining that based on the functions of the road will know in this case just be for access purposes. Therefore, it means that people will be moving at a very low design speed, so maybe 50 max. So in that case, therefore, I can provide minimum lane width, approximately, let's say I'm providing 2.8 meters there. And then the slopes and what have you, I'll just use the default parameters for this particular case. Then I'll put that lane into the left of my assembly. I come here and select a different side. So I'll say this is going to be the left one. I put it here. So I'm building up the road basically defining based on the corridor. So in this case, I'm also assuming that the corridor for developments within a residential estate, for example, we'll say that the corridor barely exceeds 12. Some of them are even 5, 6, 7. So I'll assume this case it is still 12. So I've only added the lane. So the next thing I will now need to do, I will quickly add, let's say, a curb. So we are going to have a curb. So I choose again the type of curb that I want to have. So it's just a matter of using the inbuilt properties and the design parameters that the engineers will look at, based on how they want the road to be looking like. So I'll choose the curbs. After having chosen the curbs, I'll come again and choose. I'll say that from the curb, we are now having, let's say, some trenches beside the road. So basically showing like whether you are having the drainage, is it going to be an open drainage, closed, or what have you. So like I'm just going to choose this one, that the trench is going to be combined from the shoulder there, going through up to that other side. Then I select also for this particular side. So that's basically what I need to do. Then quickly I will choose what we call daylight to basically define how I finish out the road going to the existing surface. I'll just say this. I will say that you should create outside there a small daylight to finish up the project, to basically define that existing road, proposed road plus the existing surface. So that's typically what I will do. So I'm doing it just following the specific requirement of what has been planned for the road reserve, for example. So like I'm assuming that I need to ensure that the minimum width here must be 12, meaning that the length to the center, from the center going to the left should be 6, and also from the center going to the right is 6. So I'll just add the sum of the lane plus the curb plus the channel and plus something to do with the daylight. So once I've got that, what I now need to do quickly is to define the alignment. So alignment, basically I'm going to define alignment from the start. So I'll say that I use alignment creation tool. So I'll give the alignment a name. So this alignment is still defining my street 1 that I've mentioned street 1 is going to be the center line of the alignment. Then I will say that the design criteria, I'm saying that I'm defining the design speed of this particular road, for example, that the road should be defined at 50 kilometers per hour. Then criteria based, I'm choosing the specific design standard, like I'm using ASH2, for example, the design of that particular road. Then I say, okay. So as I've said, okay, I'll say that this road should be having curves and straight. So I want to say that the road will run from this. So I want to take the center of this particular reserve. So this is the area which has been reserved for that particular road. So I'll say it run from point A, going through, coming from that point. Then there is a curve. Then it comes maybe up to this particular point. So if I click escape, you can now see it can now start quickly telling me whether there are some violations. So those are some of the concerns that the engineer will now have, which I don't want to go to the detail. I don't know maybe if they're the right people to discuss that with, but you can see it will now tell me whether there are some violations with the design in terms of the minimum curve design, the minimum speed requirements. So I can also open that in form of a table where it will show me all those design requirements based on the values of the curve, the design constraints, the conditions that have been specified, like the radius values, the design speed, the direction of the road, the delta angle, and the chord. Just to ensure that when people are moving across that road, they don't really make sharp bends that will result into the effect of centripetal and centrifugal forces. So I would not want to go to that detail. So what I now need to do, I'll repeat that same one, but somewhere where there is the surface here, I'll repeat the same procedure so that we can develop its profile view. So I'll now call this street 2, just for illustration purpose, and then I say okay. But I just want to use where I have the topo as opposed to that one because my topo didn't extend to the project area. So I'll just say it's going to be like this one as maybe my road, for example. So what I now need to do, I'll create the profile view of that. I'll create the profile view of the road and link it together with the assembly. Just to show how that happens, I'll say create the surface profile. So surface profile here, I'll call it the street 2 surface profile. I want to create it from the existing surface, then I'll just say draw in profile view. Then I'll use default parameters there. Then I'll say create in profile view. Just to quickly locate, I'll put it adjacent to this to the assembly here. Just to show how quickly integrating GIS and CAD we are able to get even our existing proposed profiles against the existing. So basically this is how the topo runs right now. So you can see from there, I'm able to get based on the topo, this is how the profile runs, where the road is proposed. So what I now need to do is on that, I can quickly do what you call a design profile. So I'll say profile creation tool. I'll select the profile on which to put it. I'll again just use the default parameters there and quickly say that even though this is how the topo runs, but how deep or shallow should we cut to just ensure that there's the smooth ride along that particular road when it is going to be constructed. So I'll just define that from here. Maybe we can just do some filling. And as we do some filling, it will be a curve. Then we can do some cutting there. We can do some small filling in this particular area and form some cut again, going through up to the end of the road, for example. So just trying to establish a balance between cut and fill when developing the design. Then I can now end at the end of the road here. Then I'll just escape. And again, you can quickly see with this, maybe I can now turn off the map just to allow you to see the way I've now done a proposed surface alongside the existing surface, besides the information that were published from the GIS platform. So I'll just say right now, maybe my map is not of significance. So I'll just say off. So you can now see this is how the terrain runs, but this is how we are constructing it now, in that we should be cutting some areas, and it provides me with a lot more information about the geometric design of that particular road that should be followed. So what I now need to do quickly is to, on the same context, is now to create what we call corridor. So corridor basically now is going to combine both the assembly, the profile, and the alignment, so that the road can be complete with respect to the context of where it was being designed. So I'll just say that this is my assembly here. Say this is the street 1 corridor. Then for street 1, then I'll say that's the profile. Then I'll say this is the assemblies for the street 1. Then I'll say the surface, use the existing surface. Then I'll say okay. Then what I'll now finally do is just click apply, rebuild. So if I quickly check on the example I was using, we should be able to see our corridor defined. So the corridor should follow, ideally the size of the corridor should be falling within the reserve. So you can see some areas where there is excessive cut and fill. So those are some of the details that the engineer will later on deal with, just to ensure that the design does not go outside the extent of the road. So I can quickly visualize that in what we call the object viewer here, just to show you the corridor. Basically like this now is showing the road, were it to be constructed with respect to those other, like the cut, the fill, the lanes, the drain. So you can also see, if you look keenly, you should be able to see the proposed drain in 3D. Like this is where we arrive at the drainage, but this is where we are filling back to the existing surface. This may be the walkway, this particular area. This is the curve where the cursor is. And these two are the 2 lanes that the vehicles will be driving on based on that particular proposed design. So the same procedure would also apply, like where I'm having, like if I was to proceed further and develop even the pipe networks, I can either proceed to do the proposed ones, like I see these are what has been proposed based on what we got, like this, the manhole. Again, I can visualize on that manhole and quickly verify if the design requirements are met. So like I can select the manhole and just verify that is the correct size been given, is there correct elevation, what are the specific network details, and if you analyze it, or let's say the rain was to fall today, how much amount of water can that manhole carry before it comes to its full capacity. The same also applies to this particular the pipe network. If I go to the analyze the gravity pipe, again, I'll need to check on the specific computational requirements in terms of the energy and hydraulic grades that defines the performance of the pipe, both at the upstream and the downstream. Okay, so that's basically what we prepare